Okay, so welcome back again, and this is Chipmaster, and in this video series I'll be repairing a MacBook, and it's here, and as it says hard drive not reading. Right, so it says here hard drive not reading, so it's not detecting the hard drive. So let me power it up. This is the first time I'm getting this thing. I got it yesterday, and they gave it to me to repair. All right, so it's on. Yes, it's on. So we have the Apple logo. All right. So the tech told me that she tried to reinstall a Mac OS on it, but she's not seen the partitions for the hard drive, so she was unable to do it. So as you can see, we're getting a folder icon, right, indicating that it needs an operating system. Cannot find a boot picker, right? So there's no boot picker, but the Mac OS recovery is there, but we need to install Mac OS itself. So as you know, the regular command to go into the Mac OS recovery is using the command R key, because this is I believe it's a type C based machine. Taking off the back here, it's a bit tight, and it's a A1706. So it's a 2016 MacBook Pro A1706, and they said it's written here, it's a 500 gigabyte SSD. Alright, so it says 2016 MacBook Pro i5 processor, 8 gigabyte of RAM, 500 gigabyte SSD drive. Okay, so I'll take it apart. Let me just turn it off. Alright, so let's head over to the overhead camera. Oops, sorry about that one. So I'm just taking it apart now. Alright. Alright, so I'm doing my first rule of repairing, using my eyes, visually inspecting. So you can take a look as well. Alright. So these are the NANDs. And this NAND, this is an Intel based MacBook, so the NAND chips are using the PCI Express bus and a control chip. Right, they are using, these are the NANDs. So this is a NAND here. Oh sorry, this is the NAND controller. Oh sorry, these are the NANDs, and this is the NAND controller chip, which is connected to the Intel CPU. Let me zoom out a bit. Alright, so these are the NAND chips. This is the NAND controller chips, right, or the SSD controller, right, and these are the NAND chips, right, and it is connected to this controller, and the controller now is connecting to the PCI Express 4 speed, and these are normally PCI Express 1, right, so they are split up into 4, 1, 2, 3, and the other one on the other side is 4, so one speed for each lane, right. So this is the PCI Express controller to control each SSD, which is talking to the CPU through the PCI Express 4 lane. Okay. Alright, there's another NAND. So I'm just inspecting the NAND. Alright. And there's another one. Oh, that's the Thunderbolt chip, sorry. That's the Thunderbolt chip. That's for the Intel Thunderbolt for differential signals. And this is the NAND controller chip. It's a bit tight there. Right, so this is the NAND controller chip right here. Alright, so this is the NAND controller chip, and these are the NANDs. So this is one NAND here, and this is another NAND, as you can see. So I will be continuing to disassemble. Any form of liquid spill or any burn, so I need to check the other side of the board to see if I'm seeing any form of corrosion or mildew or explosion. And it's all clean, as you can see right here. The liquid intake mark indicator here is white, so it's indicating to me on both sides. As you can see, the other one, it's all white. That means there hasn't been any liquid damage on this computer before. Okay, so I will continue the disassembly process. There. This flex here for the fingerprint and power button is very fragile, easily to tear if you don't know what you're doing, because it's glued down to the board. Oh, I didn't remember to remove the battery. Why didn't you remind me to remove the battery? This is the second time this is happening now. I keep forgetting to remove the battery. Ugh. Why couldn't you have reminded me, guys, to remove the battery? Also, this connector here is used to connect these NANDs together along with the PCI Express 4. Sorry, this is used to connect the PCI Express 4 with the hard drive controller or the SSD controller. If I disconnect this, then the NAND will not work. Right, so this is the connector that is going to create a path for the NAND controller, which is connected through the PCI Express 4 to the CPU. So it connects through this line all the way to this line, and then distributes that information to the NANDs, and it goes in that way. So if I unscrew this, the NAND's SSD will not work. Alright, so I'm gonna just remove it now using my index finger here, as you can see, and it feels loose. There we go. Yeah, so let's check the other side. Alright, so I'm seeing some dust here and stuff. Let's take a look. Alright, so I'm seeing some dust here. And some dust here. It looks like corroded to me. Slightly. Alright, this is the T1 chip. This is the T1 chip right here. This is used to control the touch bar. It's also used to control the fingerprint and Apple Pay. And it connects to the CPU through the USB 3.0 bus. Right, so it connects to the CPU through the USB 3.0 bus. Alright, so I'm looking on this side. As you can see, I have some dust here, just some slight dust. And on this side, here are the other sets of, here are the other two NANDs here. Right, as I can see, I see some rust right here on the inductor here. Right, there's a rust there on the inductor. Alright, There's some rust there on the inductor and some small debris here, right here beside the PD third, the PD, the power delivery chip here. So I'm just gonna get the brush and brush. All right. Okay, so first I'm gonna check the resistance. These NANDs, these coils are used to power the NANDs. So I will have to get the multimeter to measure the resistance on these NANDs. Okay, so it's now cleaned. So as I said, I'm going to check here under the microscope as well for more in-depth visual inspection. So let's go over to the microscope. All right. So looking at it now, it is a slight corrosion to me. It seems as corrosion. All right, so going over to the multimeter now. All right. Let me just get the picture in picture. So I'm going to measure the corrosion, I'm going to measure the resistance. Let's see if I can. Alright, so let me see if I can measure the resistance on these pins. On these coils, sorry. Alright, so let's go. I get 263 here. So normally this is 1.8, 0.9, 2.5 volts. These are parallel. So it's 2.5, 1.8, 0.9. I can call it. Alright, so we have so this is should be 2.5. Let me see if these are in parallel. Yes, they are in parallel. So these should be 2.5 volts and these are not in parallel. Oh, they are in parallel as well. I would have to get the schematic for this unit to confirm, but I believe this side is for the, oh, we have some small coils here as well. So this should be 1.8 volts. This should be hopefully maybe 2.7 volts, 0.9 volts. I would have to get the schematic to confirm. Let me check the resistance here. I get 138. Yeah, so they are connected. So this part I get 256. I get 326 here, and these are some LDOs. Okay, these are some small capacitors here. So I would have to head over to the schematic. Let me just clean right here. Let's just cleaning it here with some 99.9. Yeah. Let me see if we are getting voltages here first. I'm just connecting just going to get the DC jack type C port. Alright, so just gonna connect the power now. Alright, so I'm connecting the power. Alright, so let's get it over to the multimeter. See if we're getting some voltages there. Alright, so let's see. And I'm not getting any voltage there. And this side, no voltage. This coil, no voltage. See if I'm getting 12 volts. This is the output. Alright, so I'm not getting any voltage there as well. So I'm gonna check around the NAND area. Alright, let me go back under the microscope. Under the microscope. So I'm gonna check in the NAND area, the resistance to ground on the NANDs. Alright, these coils, these capacitors here, in this area I'm gonna check. here we go. Alright, so I get 319 there on that one, and this one. 319 as well. And around the hard drive controller section there, and this one should give me 319 as well. Yes, 319. So all is well, but I'm not getting any voltages here, so I'm going to check with the schematic now to see what's going on the circuit here. So these are, as I said, these are the two NANDs. This is one NAND here, another NAND here, SSD NANDs. Just peeling off this plastic to take a peek. Not necessary. Alright, so I'm going to go for the schematic. Okay, so as you can see, I have the board view here. So this is the side that is of interest. So let me rotate it to the angle at which I'm looking at physically at the board. So as you can see here, we have L9341 and we have PP 1.8 volts underscore switch 1. So this is the switching side and this is the output side. So this is 1.8 volts. As you can see, it's in parallel. On this side we have PP 0.9 volts and this is also parallel, and this coil is 0.9 volt fixed. Okay, so this SSD doesn't carry a 2.7 volts. Looking at the, yes, there's a 2.7 volts. So 2.7 volts, 1.8 volts, and 0.9. So we have 1.8 volts SSD core. We have 2.7 volts for the NAND VCC core supply, and we have 0.9. 0.9. Not seen it. 0.9. So it goes to SSD regulator. So the 0.9 volts doesn't goes to the it goes to the NAND SSD controller chip. That's 0.9 volts. As you can see, 0.9 volt SSD regulator. So it's sent to the SSD power supply here. Okay. Alright, so let me go back to the schematic. Alright, so we are not getting any voltage here, no 0.9 volts, and I need to find the PP 2.7 volts as well to see where it originates. So it's coming from the chip itself here, from the power supply chip. So this is the NAND main power supply chip, and the 2.7 volts is coming from the chip itself here, pin 43 and pin 33. Right. So it's powering the NANDs through these two pins. Let's check it to ground. So I'm going back under the microscope now. So let's confirm with the schematic board view. So 2.7 volts. It's under the NAND, so I have to remove the plastic so I can check the resistance. which is a 128 gig. As you can see, it's a 128 gigabyte SSD NAND. Right, so it's small capacitors here. Measures. Alright, so I'm getting 317. The resistance is perfectly fine. Alright, so the resistance is good. Alright, resistance is okay. See if we're getting 2.7 volts. Yeah. Alright, so 2.7 volts is there or not? No. No 2.7 volts there. And as we are here, this is 0.9 volts, no 0.9, 0.9 volts fixed, no 0.9, alright, 1.8 volts, no 1.8 volts. So the NAND is not getting no power whatsoever. So under what conditions does the NAND needs to be powered? What must be present first? What is the working conditions in order for the NAND to be producing, to get the power supply from the NAND controller IC through to the power management chip? So the NAND controller IC will control this chip, right? This is the NAND power supply, or the NAND PMU chip. So we need to check the working conditions of this chip for it in order to work, right? So let's get over to the schematic. Okay, so I'll head over back to the schematic now. Alright, so here's the schematic, and we have the board view right here. Alright, and this is the side that we're working on. Oh, sorry, I was wondering where is it. Alright, so as you can see here, this chip, this is the SSD power supply, or power management chip, right? And it's outputting 0.9, 1.8 volts and a fixed 0.9 here, as you can see. So we have 0.9 fixed, we have PP 0.9 underscore SSD underscore REG, and we have here, which is 1.8 PP 1.8 underscore SSD underscore cold. Alright, so we need to find this chip working condition, U9300. Alright, so let me get the search bar. Alright, so it's U9300. Alright, so as you can see, U9300 sectioned into different pieces. So we have 4 of 8, right? Let's do 9200. So U9300, 2 of 8. So 2 of 8, 1 of 8. So this is all the sections on this page, right? 4 of 8. And here we have 3 of 8, 1, 6, and 5. And here we have 7, right? And so it's a total of 8 and 8 of 8. Alright, so what is working conditions of this chip in order for it to produce these voltages? Alright, let's start from the first side. So the first section, so we're going to look for some signals. So we have, for example, PMIC low power, PMIC external clock. We have a I2C line here, or SM bus. We have a reset signal here, right? Let's go over to this side. All right, we have box, and this box, which is 0.9 SSD fixed. All right, this is 1.8 SSD hot. All right, and here we have the supply, which is VDD buck 1. Right, supplying VDD buck and VDD buck 5. So we have buck 1 feedback, we have buck 1 phase output, we have the feedback, and we have the output. And this is the ground for the buck. So we have 3.3 volt S5 underscore SSD. We have to check that. Right, here we have buck 0, 1, and we have buck 1. So this is the 0, 0th order, and this is the first. And it outputs LX buck 0 underscore LX, which is 0.9 regulator switch. And then the output, as you can see here, PP0V9 underscore SSD underscore REG. And we have the supplies for it. And this side we have 1.8 volts, which is a buff under 1.8 volt SSD cold. We have a PICC0LO V pump, which is a boost. So this is a boost capacitor going inside of this chip for boosting the voltages for the upper MOSFET that is inside of the switching. Right, we have sensing. Right, we have under voltage protection, which is the current. Right, 1.2 volts cold in. All different supplies. All of them. And this is the ground pins. And we have the power good, and the write protect, storage latch, and so forth. So all these signals are controlled by the SSD controller chip. All these signals for it to work in order to output the different voltages. Alright, so let me take a look at the PMUIC as well, and the controller, the SSD controller chip, which is here, U8600. Alright, so we have U8600, which is the SSD controller chip. So here is it. So we have the clock, which is a 100 megahertz clock for the SSD. Right, this is the data line for the SSD. Alright, let me get the pointer fix. Is for the SSD data. XSID, right? Positive and negative. So that's 1 group, 2 group, 3, 4, right? And this one is an incoming signal, as you can see, receiving. So we have a set here for receiving, transmitting, sorry, and this is receiving. And this is the receiving side, RX. Right, all this section here is for the receiving. Okay. And here we have a SPI section for reading this. That's a chip select. SSD boot LB underscore L. This is going to control a switching for the PMU IC. So all this information is controlled by this chip, which is the PCI Express controller. Alright, let's go to the next. So let's see how many sections this one has. So we have 3 of 7, so it's a total of 7. Let's do 8600. Okay, we have 5 of 7, which is the main supply, VDD. But we weren't getting any supplies, so VDD 0.9 for SSD, which is the core supply for the PMUIs, for the NAND SSD controller chip, VDD. As you can see, all these VDD pins are 0.9 volts, and I wasn't getting that also. So here we have PP 1.8 volt SSD cold, which is phase lock loop. PLL stands for phase lock loop. Alright, for the internal clock. So this is coming into the chip, the controller chip, for the phase lock loop clock, VDD PLL. All these are phase lock loops, 0.9 volts of 0.9 volts PLL. Alright, and here we have the ground pin for the controller. Here are some more ground pins for the controller. Alright, so it stops there. So that's how many? So this is 7 of 7, 6 of 7, alright, supply, and that's 4 of 7, PCI VDD. This is for the PCI Express, 0.9 volts fixed, and this is coming to the controller chip from the PMU IC. Alright, and here we have all these 0.9 volts, which is a part of the core supply, and for the phase lock loop section as well. 1.2 volt SSD cold. This voltage I didn't check for this one, so let's see who's sending this voltage. I'm copying it, paste. Alright, so let's see who's sending this voltage. Sometimes these chips produce the voltage and send it back to itself to another section inside of the chip. So there's VDD12 underscore DRAC underscore CK 3SX underscore VDD12 VDDR12 underscore CK underscore plane, and it's coming through this coil here, and then it becomes, and this is PP 1.2 volt SSD cold. Let's see the other section, and we have here 1.2 volt underscore cold underscore out. So it is sent from U9300. So U9300 is sending this 1.2 volt underscore cold underscore out. So let me check and see if I'm getting this voltage right at any of these capacitors. So that's C9356 or C9357, which is not installed, no stuff. So I'm going back to the microscope. All right, microscope in action. All right, so it's C9356. So I'm looking for it now. C9356. And C9356 is right here. just getting the focus. Alright, so here is C9356 right here. Oh, let me get the multimeter. Alright, so here's it. And I'm not getting 1.2 volts. Oh, sorry, it's not on. I've turned off the switch. Alright, so let's check now. Alright, so I'm waiting for the machine to turn on. It's now on. So I'm not getting any voltage here. Alright, 1.2 volts is not there. Nor 0.9, nor 1.8 volts, nor 0.9 SSD fixed. None of these voltages are generated. So I'm just checking the input voltage here, 3.3 volts. 3.3 volts is there, but I'm not getting 1.2 volts here. So let me check the resistance to ground on this chip, on this capacitor, sorry. Alright, let me check the resistance to ground. And it's good, I'm getting 248. All good. Alright, so I get 3.3 volt S5, which is the input. Remember, we're checking 3.3 volt underscore S5 underscore SSD, which is the supply. Right, so if you look at this over here on this side, right, so we're not getting the 1.2 volts here, right, PP 1.2 volts here, right, we're not getting any of the supplies coming out for the cold nor the hot, right, we're not getting anything out of the chip. So our next thing that we need to check now is the turn on signal for this chip. Well, so most chips, as they get the power supply, they will immediately start to work. Some chips need the enable signal. Alright, so let me go back to U9300 from the beginning. So this is the section that we're looking at, which is a 3V3S5. We already checked this at the capacitors, and we're getting 3.3 volt S5 for the main bulk power supply. Right, and we need to see if you can find an enable signal. If there's an enable signal, then you need to check where the enable signal is coming from. So like for here, we have to check here as well. So I'm going to check the data line, the voltage and the resistance to ground for this I2C line. Alright, this is a communication with chip, right, between the SSD controller and the PMU IC. Alright, here we go. See, you're coming from this should be U9200, U8600, sorry, which is a PMU this SSD controller chip. Right here, and we have another one here. Which is this is for another SSD. This is SDA alert. We have supply and ground, and this is also acting as a MUX, I believe. So we need to check here as well. But we're not getting 1.8 volt SSD code either, and this is used to pull up the lines to talk to so that they can communicate through the I2C line. Alright, so we won't be able to check here because we're not getting 1.8 volt SSD cold, which is coming from here. 1.8 volt SSD cold. We are not getting any voltages right here. All right, next, top side near the south of the NAND. So these are used to detect, as I said before, these are acting as a barrier or a mux in order for the communication, and it acting as a protection as well. All right, next, we have power OK, DUR, debug, not important. So I'm looking, I don't see an enable signal as yet. We have an enable signal here, which is LPSR underscore EN, storage EN. All right, we have a PD, PCI Express clock request. All right, so that's going to send the clock request to the SSD controller for the clocks, 100 megahertz for the NAND. Alright, so we have a power good here. This most likely is coming. Should stop here, but on the next side there is no voltage because the latch is closed. Storage latch, SSD power request. And this is ground. Let's see over here again. 1.2 volt cold in, 1.2 volt cold out. Alright, so we check this, so we need to check if the in is coming. And it's coming from our SSD controller chip. As you can see, and it's coming out of the chip, and it's coming out of this U9300 coil here, L9330. Right, so that's the, so let me check here on the, so L9330 is here. So it's 1.2 volt SSD underscore hot, SSD hot. Alright, connecting the power. Let's see if I get anything here. Oops. Nothing. Alright, let me check the resistance to ground. Oh, we have a short here. And we have a short here. Oh, sorry. Alright, this is PP 1.2 volt SSD underscore hot. And I'm getting a short here. Right here. On this line, I'm getting a short. This is, right, so right here is a short, as you can see. And PP 1.2 volt SSD hot is shorted. Right here is short. So could be the short on this side or it's on this side. Can anybody tell me? Alright, so I'd have to move, or I'd have to remove the coil first to see if it's on the output side or it's on the switching side. Right, as you can see, SW stands for switching. P 1.2 volt underscore hot underscore SW stands for switch. And this is the switching side, which is having the internal upper and lower MOSFET switching inside to produce this 1.2 volts. With the help of these filter capacitor to smooth out any spike and to stabilize the voltage. Right, so that's work out of a typical PWM circuit. Right, and this is outputting 1.2 volts with how many current? Let me see. And this normally tells us how many current is passing, a maximum of current that it can output, which is 2.2 ampere of current, as you can see, which is a 1 microhenry, sorry, right, inductor, right, with 20% of inductance with the 1 microhenry, sorry, of inductance, and that's 2.2 ampere, right? So I'm getting a short here. So could be that the SSD, could it be that the PMU IC is broken, or could it be that the short is on the rear stage? So let's remove the coil. Oh, sorry, I wasn't on the schematic. So as you can see here is 2.2 ampere of current, right? And this is the PMU IC, and it's a buck. As you can see, it's a switching inside, and it is the switch inside here, right? So this side, as you can see, which is PP P1.2 volts underscore hot underscore switch. The SW stands for the switch, right? It wasn't on the recording screen a while ago, so I'm just repeating what I just said, right? So this is the PMU IC. I'm having a short here, and this is controlled. This is the output coil, which is controlled by the PMU IC here, and that's outputting 1.2 volts hot underscore switch. This is the output side, which is the hot side, right? So I'm saying that if the short is on this side, we don't know the short is on this side, right? So I need to remove this part, this component, this coil, in order to see which side is having the short. Okay? Alright, so let's do this. Eh? Yeah, so alright, so I'm gonna remove this coil. Alright, so I'm gonna check now, see which side is having the short. Okay, so this side is clear, this side is shorted. As you can see, this side is shorted. Alright, so I'm gonna check this capacitor here. So let's take a closer look at it. Sometimes you can see the cracks. If it has a crack with the naked eye, you can see it with the naked eye. Alright, I'm not seeing anything, so I'm going to remove it as well. Alright, so a call came in. Sorry about that again. So I'll remove this capacitor here. Okay, slipped from my tweezer. Alright, so I'll check the resistance there again. Still have a short. Still have a short here. Oh, it's now short. The short is now gone? Really? It's now gone. Let me check this small cap here. Oh, this tiny cap was shorted. Wow, look at this small cap. This is a picofarad capacitor. It's white. As you can see on the capacitors, the darker the color, the larger the capacitance. The lighter the color, as you know, the smaller the capacitance. And I'm touching these two ends together, pin number 1 and 2 of the capacitor, and I'm getting 000. So that's a wire. So this was a problem. And it's a picofarad capacitor. So let's check here again. and I get 251. So this was the problem. So as you can see, there was some slight corrosion here. So most likely it corroded these capacitors here at the edge of the board. So it's a common problem with these MacBooks, where the edge of the board, where the vent is, always have liquid spill coming in, or any form of liquid always enter from this side, causing the damage. If you notice on these MacBooks, all of these Type C MacBooks with this design, the vent on the side is it's like a nightmare. So I'm getting 260 now. It's a poor design. Alright, so I think this is a 0603 capacitor, and this is a 0201 size capacitor. So I'll just replace this one and replace this, and put back this capacitor here, and put back the coil here, and see what I get. Alright, so I need a 00. I'm going to put back the 0603 capacitor. Where I put it? I can't find it. Where is it? I'll have to get a new one instead. Alright, so I'm just going to tin this with some leaded solder. Alright, so I can install a new capacitor here, and another capacitor for this small one here. This is a 020 size capacitor, 0201, and this one is this is a 0201, and this is the 0306 0603 capacitor right here. Alright. Alright, so I'll replace that one with a new one. Just now gonna tin the pads now for the 0201 capacitor. Alright. Some more heat. Alright. Alright, so I just there we go. There we go, there we go, there we go. Huh. Come on. Alright, so I'm now cleaning the area with some 99.9. Alright. Now the area is cleaned. Alright, so I'll put a new 0603. The one that I took off, I can't find it, so I'll just have to put a new one. Got blown away. Let's look for another one. Why am I saying let's? Doesn't matter anyway. Yeah. Okay, so I have here the new 0603 here. Oops. Alright, so this is the new 0603 capacitor. And let's add some flux for sticking purpose. I'm now adding back the coil. This inductor, I can call it a filter. It's an inductor. Alright, so I'll now add the 0201 picofarad capacitor. So let's go back to the schematic. So this capacitor here, as you can see, C9337. C9, sorry, it's C9337. What did I look for a while ago? C9, oh, I put an N. C9. Right, so it's 12 picofarad, as you can see, and we have 1000 picofarad here. These are the two capacitors. That's on the one PP 1.2 volt underscore SSD underscore hot. So this, as I said before, when the white capacitors are picofarad, right? So the color differentiates the capacitor. So the darker the color, the larger the capacitance. The lighter the color, the smaller the capacitance. Alright, so I'm going to look for that capacitor now. Okay, so I have here a new one, 12 picofarad capacitor. Can go higher with the value if you want, but not lower. So I'm just adding some flux at the end of my tweezer here to take up this capacitor. There we go. Put it back inside of the tray, and then our target spot. So let me add some flux here before. Right there. And so then that new picofarad capacitor, 12 picofarad. Don't go, don't go. There we go. 12 picofarad capacitor. Let me check. Now I'll get 198, 200. The board is hot, so the resistance will decrease a bit, and when the board is cool, it will increase. Alright, so I get 238. Alright, so I'll now plug the power to the board now and see if I'm going to get some voltages now. Yes, as you can see, I'm now getting 1.8 volts. Oh, sorry. And the current is increasing on the DC power supply as well. Is this focus? Alright, so here, let me zoom out a bit. So I'm now getting 1.8. Let's see if we're getting 0.9. Excellent, we're getting 0.9 volts now. Right, let's see if we're getting 0.9 SSD fixed. Excellent. Let's see if we're getting 1.2 volts here. Excellent, 1.2 volts is there. Okay, and all the rails that we're missing, we are now getting. Let's see if we're getting PP 2.7 volts now, which is right here, 2.7 volts. Excellent, so I'm getting 2.7 volts here. So let me move the power. Oh, sorry. Alright, I was just alright, so as you can see, that one wasn't too bad. So now I got all the voltages on the power supply rail for the NAND chips, which is controlled by the SSD controller chip, which is controlling the 4 of these chips. So 1, 2, 3, 4 chips, as you can see, right? And I'm going to put this unit back together again now and see if it works, because the customer didn't want to lose their data as well. So the technician asked me if I could do a recovery. So I said, well, depending on what the problem is, if it is, once it is repaired, then automatically I don't have to do data recovery. If this is a case like a fault like this, if the drive wasn't getting any power, or if the NAND was failed, then I couldn't retrieve the data. Alright, so I'm gonna put back this unit together now, shall we? Alright. There's one. There was another screw. Oh, here is it, I think. Alright, so I'm just going to put back these shields. This part is very delicate, the power switch. Easily torn if you don't handle if it's handled improperly. You will tear this thing. Oh, oh. Wi-Fi antenna. This one is a bit short. No. Oh, there we go. Okay, so now I'll just put on these screws and connections. Alright, so for time I will just pause. Okay, so we're almost at the final step. Now connect the battery. Alright. So just double checking, all intact. It's connected, everything is connected. Alright. Alright, so I'm gonna turn on the lid now. Alright. So turning on. Let me connect the charger. It's not turning on. Let me see what I did wrong. Let me check this side first. Okay, all is well there. Let me disconnect the battery and leave it out, see if it turns on. Alright, so I'm getting, yes, it's on. Alright, we got the Apple logo there. Oh, and it's loading the operating system. Now you can see that the operating system is now loading. As you can see, the progress bar. There we go. I have the mouse. There we go. So it's now up, and the keyboard works. Yes. And it works. Alright, so I'm just gonna screw up at this in a moment, connect back the battery and stuff. So I hope you enjoy. I hope you learned something. I hope you see how the process is when troubleshooting these types of faults on a MacBook, right? So as I said before, this is a common issue with the Apple computer, where the vent on the side here is prone to liquid intake and causing all these problems on the MacBooks at the edges of the corner here. So most of the time the damage is done on the edges of the board, right? Damaging the CD3215 or CD30, this the power delivery chip. As you can see, damages the NAND power supply rail there for the PP 1.2 volt switch hot, and so forth. Alright, so as I said before, I have a lot of work. Right, I have maybe about 20 more laptops to repair. I can't repair them today, not all of them, but I'll try. So I hope you enjoy, and I'll see you again in another video when I will fix something for you. Alright, bye.